Hello everyone, I'm Rajasri, Assistant Professor, Department of Electrical and Electronics Engineering, working at MLR Institute of Technology, Hyderabad. And in today's lecture, we'll be discussing problems based on choppers. And here, when a chopper circuit is operating on time ratio control at a frequency of 2 kHz on a 460 volt supply of the load voltage of 350 volts, calculate the conduction period of thyristor in each cycle. So here this is basically a chopper that is understood. Calculate conduction period of the thyristor in each cycle. Conduction period in the sense on period of the chopper we are supposed to calculate. And before solving any problem, let us write down the given data here. And here frequency is given, which is given by 2 kilohertz, and voltage, supply voltage Vs is nothing but VDC, which is equal to 460 volts, and the load voltage, that is V0 average, it is given by 350 volts. In that case, we need to find out what is on period of the chopper. Firstly, let us see what is the formula for V0 average. And since this is chopper, we have V0 average is equal to delta Vs, where V0 average is given in the question, that is 350 volts, delta is not given, delta into Vs is 460 volts. And here, since we need the value of T on period, let us write down the delta. We also have the formula for delta, that is T on by T, is it not? Delta is given by T on by T, where we can also write this formula as T on by T on plus T off, where T on plus T off is nothing but total time period of the circuit. So here, let me substitute 350 is equal to T on by T into 460, where on period of the chopper is equal to 350 into time period by 460, where here time period is nothing but 1 by frequency, is it not? Time period is given by the formula 1 by frequency, where frequency is 1 by 2 into 10 to the power of 3, that means 0.5 into 10 to the power of minus 3, that is 5 into 10 to the power of minus 4 seconds we can write. So here 350 into 5 into 10 to the power of minus 4 divided by 460. If we resolve this, we will get on period of the chopper is equal to 380 microseconds. Yes. Now, let us see the second problem. Considering the switch to be ideal in the circuit of figure, determine the duty cycle for which output average DC voltage and RMS voltages are equal. And the second case, you need to find out the chopper efficiency. So here, considering the switch to be ideal, he is saying, and in the circuit, you need to find out the duty cycle for which average output voltage and RMS voltage, V0 RMS is equal to V0 average according to the given data. In that case, you need to find out the delta first. And the second bit, he is asking you to find out the chopper efficiency. And let us consider the first case, where V0 average is equal to V0 RMS. That means since this is chopper, we have V0 average formula is delta Vs, whereas V0 RMS, it is given by the formula root over delta into Vs. Is it not? So Vs gets cancelled. When delta is equal to root delta, if at all, if we consider delta is equal to 1, that in that case both will be equal. That means this is the answer here, delta is equal to 1, that is required. And the second thing is, here you need to find out the efficiency. Efficiency of an ideal switch. Chopper is also a switch, and here efficiency is 100%. Whenever the input voltage which you are actually feeding is equal to that of the output, that means because there are no losses, since the switch is considered as ideal, In that case, efficiency should be 100%. A transistor chopper is shown in figure if DC supply of 120 ohms is applied and the transistor is switched by applying a periodic base pulse of voltage varying between 0 to 1 volt. Sketch the load voltage with reference to the input base pulses. Calculate average or DC output voltage. That is the first thing. And second thing he's asking us to find out is average load current assuming the chopper frequency is 200 Hz and the duty cycle of chopper is 33.33% and the load resistance of 10 ohm. So here this is the chopper basically and the DC supply, that means VS supply voltage, we can also call it as VDC, which is equal to 120 volts. And calculate, first bit is he is asking us to find out V naught average, and the second bit is we need to find out I naught average load current, assuming chopper frequency as 200 Hz, where duty cycle is given as 33.33%, where load resistance is given as 10 ohms. 33.33% and divided by 100, we get it as 0.3333. We can also write this as 1 by 3. And firstly, here we need the value of V naught average, where V naught average is equal to delta Vs, is it not? So here delta is 1 by 3 and the source voltage which is given in the question is value is 120 volts. So we get 40. V naught average is equal to 40 volts. That is the first bit. And then he is asking us to find out the I naught average as well, average load current, assuming the chopper frequency. Okay. So second bit, I naught average is equal to, it is given by the formula V naught average by R, where V naught average is 40 divided by the load resistance. It is given in the question as 10 ohms. Gets cancelled and this is 4 amperes. That is nothing but I naught average. That's it. And coming to the fourth problem, a chopper circuit drives an inductive load from 200 volts DC supply, given the load resistance as 4 ohm and the average load current as 30 amperes and operating frequency is 400 Hz. Compute on period and off period of chopper. Also determine the duty cycle of the chopper he's asking. So here firstly, there is a chopper circuit. VDC is equal to 200 volts. Load resistance is given as 4 ohm and average load current is 30 amperes and frequency is given as 400 Hz. You need to determine on time of the chopper, off time of the chopper, as well as duty cycle of the chopper. These three factors need to be determined, and for that purpose, let me consider the value of I naught average, where I naught average is equal to, we have formula V naught average divided by R, which is equal to 30 given. So here V naught average is equal to 30 multiplied the value of the resistance, that is 4 ohm. So what we get, V naught average as 120 volts. And once we get V naught average, we all know very well V naught average is equal to, let us write this in terms of duty cycle such that V naught average is equal to delta Vs, where delta is given by T on by T and Vs is source voltage is 200 volts here and V naught average is, we have got it as 120 volts, where we need to find out the on period of the chopper. For that, we need the value of the time period. So here T on is equal to 120 divided by 200 into time period, that we can write it as 1 by frequency, where frequency is given in the question as 120 into 200. Frequency is 1 by 400. In that case, we get on period of the chopper as 1.5 milliseconds. This is nothing but the on period of the chopper. So this is also done. And now we need to find out the off period of the chopper, T off. And for that purpose, we have time period. Time period is equal to, that is given by the formula on period of the chopper plus off period of the chopper. We know the time period and we know the on period. In that case, T off is equal to T minus T on, where T is 1 by frequency, that is 1 by 400 hertz minus on period of the chopper is 1.5 milliseconds. In that case, off period of the chopper, we get it as 1 millisecond. So that is how we can find out the off period of the chopper. And we have the last problem, that is a DC chopper has a resistive load of 20 ohm and input voltage of 220 volts. When chopper is on, its voltage drop is 1.5 volts and the chopper frequency is 10 kilohertz. If the duty cycle is 80%, determine the average output voltage, RMS output voltage as well as on period of the chopper. So that is a question. And here resistive load, let us write down the given data first. Resistive load RL is equal to 20 ohm and input voltage is 220 volts, and when the chopper is on, its voltage drop is given as 1.5 volts and the chopper frequency is 10 kilohertz given in the question, and here duty cycle is 80%, that means it is 0.8. And determine, in this case you need to find out the average output voltage. V naught average, that is one thing you need to find out. V naught RMS, that is the other thing. And you need to find out the on time of the chopper. So here V naught average is equal to, usually we have delta Vs, but since here he has given the drop to be considered, so we need to write this formula as delta into Vs minus drop across the chopper switch. So here delta into Vs is 220 minus Vt is 1.5, whereas duty cycle it is given as 0.8 volt, 0.8. In that case, we get V naught average as 174.8 volts. That is V naught average. And once we get V naught average, you need to find out V naught RMS, where the formula for V naught RMS is root over delta into Vs, where drop is also given. The formula turns out to be Vs minus Vt. Root over delta in the sense 0.8, where Vs is 220 given minus Vt is 1.5 volts. In that case, we get V naught RMS as 195.4 volts. If we resolve this, we will get V naught RMS as 185.4 volts. And he is also asking us to find out the on period of the chopper. So here delta is equal to, it is given by the formula T on by T, and on period of the chopper is equal to, we can also find it out like this, delta into T, where delta is already given and you don't know the value of the time period, and here frequency is given, and in that case time period is given by the formula 1 by frequency, and if we substitute frequency over here, 1 by 10 into 10 to the power of 3, in that case on period of the chopper will be 80 microseconds. So this is how we can also find out the on period of the chopper. Thank you.